Violet asked question 1 about what are the top 10 most common conditions in older adults who are in the bracket of 40, 50, 60, 70, 80, 90, 100 years of age. Question 2. Why? Cardiovascular disease, hypertension, atherosclerosis, stroke, and heart failure are leading causes of death in older adults.
Hello, family! To answer Violet why their parent, friends who are 40, 50, 60, 70, 89, 100 are experiencing cardiovascular diseases. Let's dive right into giving this information. Diseases associated with aging are primarily chronic, degenerative conditions resulting from accumulated cellular damage and inflammation. This is from a lifetime of consuming sugar in all forms, wheat/barley, and omega-6, the ones called cooking oils. Over 90% of adults, 65 plus, have at least one, most commonly hypertension, arthritis, heart disease, cancer, diabetes, and dementia. These diseases often co-occur, severely impacting quality of life and mobility. Top chronic conditions in older adults. 1. Cardiovascular disease, hypertension, atherosclerosis, stroke, and heart failure are leading causes of death in older adults. How age causes hypertension. Aging causes hypertension primarily through the progressive stiffening of major arteries, a process largely driven by structural and chemical changes in the blood vessel walls. 1. Structural stiffening of arteries. As the vascular system ages, the large arteries, especially the aorta, lose their elastic quality. Loss of elastin. The flexible elastin fibers in the arterial media gradually fragment and degrade over time. Collagen accumulation. Stiffer collagen fibers replace the lost elastin, increasing the overall rigidity of the vessel wall. Calcification. Minerals like calcium deposit within the arterial walls, further hardening them. Result. These stiffened vessels cannot expand as easily to absorb the surge of blood from the heart, leading specifically to isolated systolic hypertension, high top number, normal bottom number. 2. Biological and chemical triggers. Molecular changes accelerate this physical stiffening. Endothelial dysfunction. The inner lining of blood vessels, endothelium, becomes less efficient at producing nitric oxide, a key molecule that helps vessels relax and dilate. Chronic inflammation. Aging is associated with low-grade systemic inflammation, sometimes called inflammaging, that damages vascular tissues. Oxidative stress. The accumulation of reactive oxygen species, ROS, causes cellular damage that promotes arterial hardening. How aging enhances atherosclerosis. Aging promotes atherosclerosis, the buildup of plaque in the arteries, through a combination of cellular wear and tear and a chronic, low-grade inflammatory state often called inflammaging. 1. Cellular senescence, zombie cells. As we age, cells in the blood vessels lose their ability to divide properly, a state known as cellular senescence. Endothelial cells. The inner lining of the artery becomes leaky and less efficient at producing nitric oxide, which usually prevents plaque buildup. SASP factors. These senescent cells do not die. Instead, they remain active and secrete harmful pro-inflammatory molecules, the senescence-associated secretory phenotype, that attract immune cells to the artery wall. 2. Chronic inflammation, inflammaging. The aging immune system becomes less precise and more reactive, leading to persistent inflammation. Monocyte recruitment. Senescent endothelial cells express more adhesion molecules, like ICAM1 and VCAM1, which act like Velcro, grabbing white blood cells from the bloodstream and pulling them into the artery wall. 3. Structural and repair failures. Aging degrades the physical integrity of the vessel and the body's ability to fix it. Aging enhances matrix breakdown. Enzymes called matrix metalloproteinases, MMPs, increase with age, breaking down the collagen and elastin that keep arteries flexible and plaques stable. Aging also ensure telomere attrition. With each cell division, the protective tips of chromosomes, telomeres, shorten. Eventually, they reach a critical length that triggers a permanent stop signal, preventing the vessel from repairing small injuries. Stem cell exhaustion. Older individuals have fewer vascular progenitor cells, repair cells, available in the bone marrow to travel to and heal damaged artery linings.